So we should first draw a free body diagram of what's exactly going on. This will be extremely important to see exactly what is going on. So we have this. So here we have alpha, here we have beta, and we have this little pulley here, and we have a mass here, mass B, and then we have a mass A. We have here force tension of A, and we have here force tension of B. And then we have the force of gravity of A, and here we have the force of gravity of B. So this would be the full free body diagram of the diagram, and then we have the acceleration here. So acceleration is going up, or rather with the incline of the slope. So, and we have some of our givens. So the mass of block A, we'll say lowercase a. We'll just change it all to lowercase. It's a little bit easier to manage. So mass of A is going to be 8.0 kilograms. Mass of B is going to be equal to 10.0 kilograms. We have rather alpha, the angle right here, is going to be 32 degrees, and beta, the angle right here, is going to be equal to 61 degrees. And we know that A, the speed, the acceleration, the linear acceleration is going to be 1.00 meters per second squared. And then we have the radius of the pulley, which is going to be 0.15 meters. So we should first, part B is asking us to find the tension in A, the tension in B. So for A, we can say the sigma forces of A equals MA, or rather we can specify this mass and say MAA. And we can say that the only forces for A in the x direction is going to be F of t in A minus MAG sine of alpha, and this is going to equal MAA. To find force of tension, we have force of tension A equals M sub A plus M sub A G sine of alpha. And this is going to equal 8, and then it will be 1 plus 9.8 sine of 32 degrees. And this is going to equal force tension in A is going to equal 49.55 newtons. For B, it's going to equal M sub B of A, and it's the same exact thing. And in fact, we can actually go straight to this and say this is going to be F force of tension of B will equal MBA plus MBG. And here, instead of sine of alpha, it'll be sine of beta. So in this case, it'll equal 10 times 1 plus 9.8 sine, and then here it's going to be 61 degrees. So we find that this force tension in B is going to equal 75.71 newtons. So these will be your answers for part B. And then part C is asking us to find the moment of inertia. So, or we can find the torque on the pulley and the moment of inertia. So we can say, the force of the pulley is going to equal the force of tension B minus the force of tension A. And this is simply from the free body diagram here. And this is going to equal 75.71 minus 49.55, and this is going to equal 26.16 newtons. So once we have that, we can say the torque on the pulley is going to equal the force on the pulley times the radius of the pulley. And this is going to be, again, 26.16 times 0.15, and this is going to equal 3.924 Newton meters. So this will be your one answer for part C. And then the second part for part C would be the moment of inertia of the pulley. So tau equals I alpha, and we know that A equals R alpha. So we know that tau is going to equal I A over R. And once we find that, we can say that I is going to equal tau R over A, and we can say 3.924 times the radius of the pulley. So this is going to be 0.15, all divided by A, which is essentially just 1. And this is going to equal 0.5886 kilogram meters squared. So this will be the moment of inertia of the pulley. This is your second answer for part C. And that's the end of the solution. Thank you for watching.